So tonight, you will hear from Natalia Krupenko, who is a faculty member at the UNC NRI. And as you can read from her bio, she has a very esteemed background, and that she has a degree in bioorganic chemistry. She's going to talk on the subject of vitamins and whether or not they are something we should all be taking, because the research we do at the NRI has to do with your individual genetic makeup and what you should be consuming for your own personal health. And that's the focus of what we do, and that's the focus of her talk tonight. And so I give you Dr. Krupenko.
Okay, thank you, Susan, for nice introduction, and good evening, everybody. I want to warn you, I'm a little bit jet-lagged, so if I become very slow, please bear with me, because I'm supposed to see my dreams right now. Anyway, from dreams to reality, today we're going to be talking about the vitamins and health. Of course, health is the most important thing for every person. I have a friend who pulled his back one day, and when he was suffering, he said, you know what, I cannot talk about anything, I don't want anything, I just want to be well. I don't want to hurt. So we all want to be well, and we all want to be well long term. So what do the vitamins have to say about being well? Before we go to the specific information, I would like to ask the audience, who out of the present crowd has been taking vitamin supplementations? Okay, most, great. Who has been taking the supplementation that was prescribed by a physician? Okay, a lot less. And out of those, how many, please raise your hands again, have been taking vitamin supplements after being tested for the levels of the vitamin? Okay, exactly those, almost those who were prescribed the vitamins. So, looking at these demographics, we can say that you are not alone. This is the information provided by the NHANES for the years 2003-2006, demonstrating how many people are taking multivitamin supplementation. And it turns out that almost half of the population is taking multivitamins. The question is, how well do they serve the people? Do they have an effect? And it is a very important question that a lot of scientists are trying to answer. There are a number of studies done in that regard. I'm not going to talk about them now. I just want to show another thing very important with regard to vitamins, and it is the fact that it has a huge economic impact. The United States supplement industry reached 28 billion in sales in the 2010. That's a big chunk of money that all of us are paying for those supplements. And again, the question is, how well do they serve us? So some of the research says that most of the common reasons for taking vitamins is not the actual clear need, but rather the desire to improve overall health. So do you agree with that? I think this little questionnaire that I have done before shows that there's a lot more people taking vitamins than actually have been determined to be needing ones. So in a lot of cases, even physicians recommend vitamins to be taken just without even measuring the levels of the vitamin in the blood, just following the general idea that with the age, people may lose the ability to assimilate the vitamins, or with the age they require more, but without the actual determination. So the question is it important, and how important it is, and how beneficial it can be? And now let's talk about what the vitamins are. According to the Wikipedia, an organic compound that cannot be made by your body, but which is very important, which is a vital nutrient that the organism requires in limited amount, is called a vitamin. Vitamins have been discovered almost a century ago when people who were placed in the conditions with a limited access to the food supply or variety of the foods were subjected to a very monotonous diet, which did not allow them to obtain a lot of compounds available otherwise. For example, sailors that have been on a long trip didn't have access to fruits and vegetables, and they developed scurvy. And then it was found out that just citrus fruit added to their diet could fix the problems, severe problems with health. So the compounds that have been identified to affect human health very importantly, but in a limited amount, were called vitamins, from the Latin word vita, which means life. They are important for life, they are required for life. Today, I'm not going to talk about all of the vitamins because we know more than 13 groups of the vitamins, and they have been reclassified from time to time. Today, I'm going to talk about folic acid, which is a water-soluble vitamin, and vitamins A, E, and D that have been very popular lately among the doctors and the patients. And these last three are the fat-soluble vitamins. They are sort of segregated by their physical properties. Folic acid is my favorite because I have been working in the area of folate metabolism and studying the way folic acid and folate affects human health for the past 20 plus years. So I'm going to start with my favorite one. A little bit of a history. Folic acid or folate has become a point of interest for a lot of physicians and scientists in early 30s, when a British female biochemist, Lucy Wills, studied the incidence of macrocytic anemia in textile workers in Bombay. She noticed that the macrocytic anemia was showing up and associating more with the people who were of a low socioeconomic position, which means didn't have enough funds, didn't have good diet. Their diets were poor in proteins, fruits, and vegetables. So she realized that it may be the nutrient that is missing from their diets. She started doing research and working with the animals. She found that yeast extract added to the diet of the animal that have already developed this microcytic anemia could fix the problem. She tried the same extract trying to supplement the diets of the women who developed the condition during pregnancy, and also found that it was very, very helpful. She continued her studies for a while and used even newer compounds that were discovered later. A little bit closer to the 40s, another group of investigators discovered that liver extracts could be efficiently used to treat again megaloblastic anemia, another disease of blood which is related to the disturbance of cell division of the bone marrow cell division and maturation of the blood cells. That meant that there are specific compounds that affect the process. In 41, a compound was isolated from spinach, and it was called folic acid. When this compound was checked for the patients of Lucy Wills, she found that it completely fixes the problem of the anemia. So thus the folate became responsible, the folate deficiency became responsible for this differentiation and cell division defect. In 43, folic acid was synthesized in a chemically pure form for the first time and became available in sufficient amounts. Probably this is the reason why we are talking and getting it right now. Now, the first appearance of folate as a required compound, required vitamin, happened to be connected with the anemia, with the cell division. Later research over the past 80 years have shown that folate has a number of very important functions in the body, and the main function that it does is it carries a structural element of the molecule called one carbon group, and it can donate it in biosynthetic processes to help build the compounds that are necessary for cell division and function. So it is important for amino acid metabolism, for nucleotide acid biosynthesis, and for a number of other biosynthetic reactions. And all of these processes are involved in support of the cell division, growth, and that is why all of those anemias were manifesting. Now, this is the later connection of folate. I don't know how many of you have seen this picture around. I know in the 10 years ago, a lot of airports displayed it. And this picture says here in the small print that it is necessary to take folic acid to prevent neural tube defects. So in our days, folic acid and folate are mostly connected with the neural tube defects. Well, what are the neural tube defects? It is the most common fetal malformation caused by the failure of the neural tube to close. Some of you who have been here for the lecture of Dr. Patrick Stover probably have heard a little bit about this and maybe remember, but I will go over it briefly because it's very important to understand why we are at the situation we are now. Why do we all consume folic acid no matter whether we want it or not? So, neural tube closes along 5 separate sites very early in the embryonic development, between day 18 and 28. The failure to close the neural tube produces disturbance and malformations in the embryo that debilitate it or even kill it. The incidence of neural tube defects is pretty high, about 1 for 1,000 births, which creates 3,000 neural tube defect affected babies per year. And the most common of those are anencephaly, which means lack of normal head development, and encephalocele and spina bifida. This little scheme shows you what happens when the embryo is developing. At about day 18, the embryo has this little patch of the cells along the midsection of the body called neural plate. These are the initial cells from which the whole nervous system is developing. These cells start growing following a very precisely determined program. And what happens, this area becomes a little bit thicker, the edges start due to this rapid cell division, start coming up and form the neural groove. This neural groove keeps growing, and the edges go up, and then they start closing. And when the 28 days of gestation pass, these edges have to come back again, forming a neural tube. When this process does not follow the precisely orchestrated program, then there are some openings or maybe complete opening in the tube, and then we get the neural tube defect in this developing embryo. So at certain times, most of these children died, the children who were affected with NTDs. Now about 85 or 90% of them remain alive. Of course, the severity of the condition depends on the location of this non-closing element. But what happens when this tube is not closing? The neural cells that start developing inside of this protective tube, they get out of the tube and they do not develop normally, they do not differentiate normally, and create something like this. In 2005, 2007, there were a number of attempts to surgically correct this defect in utero. But even though these operations produced improvement for the future baby, they were less debilitated, they never achieved complete elimination of the program, which indicates that the cells need to be protected inside the tube at a very early stage. Otherwise, they do not form the direct connections, the right connections that they are supposed to form. So this is still a very important problem that needs to be fixed in order to avoid the debilitation in these kids. And besides the defect of the neural tube and paralysis that often is observed in these kids, 85% of these babies also have hydrocephalus, which requires removal of the cerebrospinal fluid in order for them to survive and develop relatively normally, so to say. So the problem is very important. Now, what are the causes of this? Of course, genetic predisposition, and that was concluded when it was shown that mothers who had pregnancies affected with NTD were 10 times more likely to have another NTD than any other non-affected pregnancy. Such conditions as chromosomal trisomies are also connected with the spina bifida. Some of the metabolic conditions like gestational diabetes or teratogenic drugs, some environmental pollutants have been shown to be affecting the embryo development. But the last but not least, it was shown that folic acid deficiency or defect in absorption of the folic acid by body is one of the reasons for this condition to appear. The link with folate was detected really, really early, and it was mostly observational, just by seeing again, like Lucy Wills did, connection with the lower dietary supply of the of good diets. Conception in winter or spring when the supply of vegetables and green sources was very low also was connected with a higher rate of spina bifida. And then just understanding that when the embryo grows, the nucleic acid and protein synthesis puts a lot of requirements, a lot of strain on the mother's body and increases the requirement for the folate. by mother. So, since folic acid has been suspected as the culprit in this condition, the intervention trial was undertaken. The trial started in 1983. It included 33 centers in 7 different countries. And the way it was arranged, women who have previously had neural tube defect affected pregnancies were signed up for the trial. Then they were randomly segregated into 4 groups, and each group received a different regimen of vitamins. One group received folic acid. Another group received different vitamins, but not folic acid. The third group received both vitamins and folic acid, and the fourth group received placebo, which means neutral compound that looked like a pill. It was done on 1,800 women almost. 1,195 pregnancies were analyzed, and comparison between the groups really early discovered that addition of folic acid to the regimen before the pregnancy and during the early pregnancy caused 72% reduction in the neural tube defect appearance. So this answered the question really early and really definitively. 72% difference had to not interpret. And because of the success of this intervention, the study was stopped really, really early, 7 years earlier than it was originally planned, because nobody knew what would happen. And the recommendations that have been formulated based on that trial included the recommendation that all women of reproductive age should consume 400 micrograms or 1 milligram of folic acid daily to prevent the neural tube defects. And those who have been previously affected with neural tube defects should quadruple that amount. Well, these recommendations were great. However, there was a little problem in how to implement it and how to realize it in actual reduction of the affected babies. First of all, 50% of pregnancies are not planned. And the neural tube closure happens early enough so that women don't even suspect that they could be pregnant. A lot of women don't take adequate folate as a background. 1/3 of them don't even go through the prenatal care during the first semester. So it's not really easy fix how to make sure that when the neural tube closes, women get adequate folate. Except that solution was suggested to supplement grain foods and all products made from grain with the folic acid for the whole population. The supplementation was calculated in such a way that, taking into account breakfast cereal and bread eaten with all of the meals, the average amount per day will approach 300 to 400 micrograms that are required for normal folate status of the women. So that's how we all ended up eating folic acid on a daily basis and consuming it in a variety of products. Even funnier, this picture I made the day before yesterday when I was flying from Europe. The pretzels distributed by American Airlines have folic acid in it. So even 40,000 feet above the ground level, you can get folic acid supplemented food no matter what. Folic acid was also included into the multivitamin supplementations that, again, at the level that is required for daily maintenance of the adequate folate status. Now, after the supplementation started, the monitoring was maintained to see whether this intervention had any effect, how successful it was. supplementation started right about here, 96, and that's exactly the point where the curve changes direction and goes down. So since the beginning of supplementation, there is a steady reduction of the neural tube defects, and in only 7 years, it reached about level over 30%. This is an amazing success when the supplementation resulted almost immediately in very significant improvement of the condition for which it was designed. However, there is a little bit of a drawback. The supplementation was targeting women of childbearing age who are at risk of NTDs, which is a small proportion, while the folic acid is consumed by everybody. So the question is, how good is it for us? Of course, before starting supplementation, there was a test performed to evaluate toxicity of the folic acid. And up to 10 milligrams per day of folic acid did not show immediate toxic effect like nausea, some blood profile changes. So the conclusion was made, it's safe. However, no long-term studies have been performed. And the more we go, the further we move, the more information we accumulate. So we'll learn as we go, and we find new and new data. What about risks? Some of the risks have been known, and specifically the risk of masking B12 deficiency. B12 deficiency and folic acid deficiency are independent risk factors for the pernicious anemia, which is the condition that helped to discover folic acid. Now, when the pernicious anemia is caused by vitamin B12 and a person gets folic acid supplementation, the anemia is corrected. But anemia is not the only result of B12 deficiency. Another result of B12 deficiency is neurological damage. The neural cells are demyelinated and they do not function properly. And if you give folic acid to a B12 deficient person, you will erase the blood picture showing deficiency of something. But the actual deficiency will not be corrected, and the neurological damage will continue, and it will reach the condition when it will become irreversible. So that was the concern. And due to that, it was agreed that the folate supplementation should be kept below 1 milligram per day to avoid that masking effect. It's still not a guarantee, but it does limit the amount of folic acid that is given, and hopefully we'll be able to preserve some of the symptoms. Except for the cases of neural tube defects, when you have to have higher levels to prevent defects. With the course of time and development of science, with the observation and monitoring of the intervention, several sets of data have produced conclusions that there may be increased risk of cancer associated with the folate over supplementation or folate supplementation. It is not, as Dr. Stover pointed out, it is not proven unequivocally, but these are epidemiological data that are based on statistical analysis and show trends, risks, and these parameters indicate that there may be something else connected with folate supplementation, and it may not be pretty. Well, we decided to look into this issue too. Of course, logically, folic acid supports rapidly dividing cells. Cancer cells rapidly divide, so they do need a lot of folic acid. These are some of the cancers that have been listed among the possibly connected with the folic acid supplementation. So the question is whether high dietary folate is good for everybody. We decided to study the effect of the folate diet that is having sufficient or enriched levels of folate with the folate deficient diet, the diet that have restricted amount of folate. And we used the murine metastasis model when the cancer cells that have ability to express the fluorescent protein, which means they can be detected with a special equipment by the fluorescence. These cells are injected into the tail vein, into the system, and then allowed to follow its path. And we looked what happens in the group that has low folate in the diet and the group that has high folate in the diet. So these are two mice. They have been placed on their respective diets 1 week before cell injection, and when we inject the cells, the amount of fluorescence or the amount of cells, because fluorescence directly reflects the amount of cells, the size of the metastasis. The amount of cells is exactly the same, but 1 week later, only 1 week later, we already see the clear difference. There's a lot more cells and metastases in the mice that are sitting on the regular diet without any limitation. The mice that don't have extra folate in the diet, have restricted diet, have lower level of metastasis. By the end of experiment, this difference reaches about 10 times. That is showing us that cancer is really happy to have a lot of folate. And that is not really good for the mice, because when we looked at the survival, after 5 weeks, all of the mice that were maintained on a regular diet with sufficient folate, plentiful folate, were dead. 5 weeks. Interestingly, after 9 weeks, the mice that were on the folate deficient diet, there was a couple that were still alive. So we increased survival by about 2 times. That is, again, very serious issue and very serious consideration that we need to take into account when we are talking about folate. This work has been done in collaboration with my husband, who also happens to work at the Nutrition Research Institute. We have collaborated on various different projects, but that made us both think and put a question: do we need to take folic acid? Because if there is something that has not manifested itself, some initiated cells that can become cancerous, will they be rushing along this road? Will they be speeding up? We don't know. We plan to perform experiments that would be looking at the carcinogenesis, at the process of appearance of cancer. This is the different work. But these results really, really put a big question mark about the connection between cancer and folic acid supplementation. There are still some unresolved questions. Of course, these are mice. Are the humans similar? Additional work needs to be done. Among those questions, there's a question: what are the safe limits of the dietary folate for patients with a cancer disease, with a metastatic cancer? Are there any safe limits? Maybe we can reduce the folate so that it does not interfere with a healthy function, but does not speed up cancer development. We're actually planning to run these experiments in the setups similar to the ones that we looked at. And even though everybody probably will agree with the lady that it is not folic acid, but results of our experiments and the epidemiological studies sort of point out that we should be careful. We should check what's happening. Additional question is, what about natural folates? Do they have the same effect as the folic acid? Folic acid is not a natural vitamin. I mention that it was synthesized by Bob Stockstad in the 43. And it is not present in any plants or animals. It's a synthetic vitamin. Come on, my tongue doesn't move. Before folic acid becomes useful for a cell, it has to be metabolized. It has to be fully reduced. It has to accept one carbon group. It has to be modified by a glutamate residue. So there's a number of processes involving it. And different people may have different ability to metabolize folic acid. So the effect of it can be different in different people, and it can produce various results. Maybe natural folates do not have this effect. That also needs to be investigated. But until that happens, I can show you something that can help deal with this problem. Among the folate supplements, folic acid is not the only one available for people. There's another folate supplement called methylfolate. This is a natural form of the vitamin. This is the form of folate that represents 90% of folate in our bloodstream. So those who are concerned or who are bothered by the issue of it, they can use this natural folate and control their folate level. Another folate that is close to natural is folinic acid. This is fully reduced compound. It also has one carbon group attached, but it is absorbed very nicely by the cells and quickly converted to any other form of folate inside the cell that it needs. So these two are more closely resembling the natural dietary food supply. And again, the question, how can we manipulate the diet to help prevent and cure cancer? And this is the question that we keep studying and keep addressing in our experiments, hoping to find some reasonable measures that can help us. Well, the importance of the issue of folic acid and oversupplementation with folate acid is underscored by this request for information issued by NIH in 2013, only a year ago. And it sort of recruits scientists working in the area to investigate how safe is the folic acid. Is it possible to avoid any undesirable effects but preserve positive effect of the preventing neural tube defects? So recommendations for achieving the natural levels of the folate that you obtain from the diet are: try to eat raw vegetables, because the less you treat vegetables, the less you destroy the vitamin. Try not to store fruits and vegetables for long, because again, folic acid is very labile. It reduces, it gets oxidized, decomposed, so stored vegetables have lower folate in them. Steam or stir fry, because that reduces the temperature action on the vitamin. And eat dried beans and peas, because these, even when they are cooked for a long time, they retain more folate than the fresh vegetables. Okay, let's stop about the folic acid. Let's look at the vitamin A, and I'll try to run really fast through that. How many are consuming vitamin A? Can you just show hands? Okay, there are several. And probably some of you remember that about 10 years ago, it was very popular as possible cancer preventer, just because of some of its properties. So vitamin A is a group of biologically active compounds that are important for vision. And basically that's how it was discovered. Even ancient Egyptians knew that you can cure night blindness by giving people raw liver. So there is something in the diet that corrects it, some compound. Well, later studies found that vitamin A is important not only for vision, but also for bone growth, skin and mucous membrane health, for immune system, and the list keeps growing. It's for reproduction, for cell function, and all of these things come up because it was shown that vitamin A, the compounds that belong to this group called retinoids, are involved in regulation of gene expression, and that's how they perform their action in the body. Besides that, vitamin A is also antioxidant, and that is the reason why it was actively drawn to try to prevent cancer, because it was believed, and it is believed now, that partial cause of cancer is the damage which free radicals introduce in the cells. So hoping that adding antioxidant will help was the reason under prescription of vitamin A for the prevention of cancer. Now, the sources of vitamin A are animal products, and I want to point out that animal products contain the vitamin itself, retinol, retinal, or retinoid acid. So it's pre-made vitamin, source of pre-made vitamins. It's meats, these products are meats, fish, dairy products. Another source of vitamin A are green leafy vegetables and brightly colored fruit. But these vegetables and fruits, they do not contain the actual vitamin A. They contain precursor of vitamin A called carotins. And there is a whole group of carotins, there's not one. And all of them are metabolized by the body to make vitamin A. And one more comment, cooking of these brightly colored vegetables help to convert, to prepare the carotins for assimilation by the body and increase the availability of the vitamin for the body. So when the recipe calls for sauteing your carrots or peppers or tomatoes, it is good for making vitamin A more available for the body. Vitamin A has a certain requirement for consumption. This is the established level per day. But if you are taking vitamin A as a supplement, it's relatively easier to over supplement, to increase the amount to the levels that can become poisonous. And for one time acute poisoning, it's 100,000 units. But if somebody is using vitamin A on a regular basis and a little bit over supplementing, it can be, the toxic levels can be achieved at a much lower consumption. Interestingly enough, large doses of vitamin A consumed by women can cause birth defects. So that is another concern about using the supplement and overdosing. Interestingly enough, large amounts of beta-carotenes do not make somebody sick. And they do not do so because they have to be metabolized by the body. And the body is able to control how much it turns into vitamin A. So the rest could be stored in the fat, under the skin, and the skin may change color, but you won't get really, really sick. Now, looking at the table which shows the amount of daily recommended intake in one serving of different kind of food sources, we can notice that there are a lot of foods which can provide the complete daily dose of the vitamin just in one serving. And the best of it is sweet potato. So when you go to 46 and get those sweet potato chips, they are good for you. You're getting your vitamin A.
Even if they're fried?
Even if they are fried. even if they are fried. So these numbers show us that, yes?
So that 214%, how does that relate to the 100,000 units on the last slide?
5,000 units per day is the recommended value. These are international units. Units of activity are different than the weight units. So 5,000 units equal 100% of recommended value. I don't give you the information here in the actual weight units, how much it is, but apparently a cup of sweet potato gives you this one. And it also tells you that you can get your vitamins from the food in absolutely safely in required amount. You don't need to go for the supplement while you can have something natural. Another interesting point that was shown was that when you take carotenoids, source of vitamin A, from the food sources, from the food, natural food, this may reduce your risk of cancer. This is, again, statistical analysis of the studies made in different cohorts.
Would that be skin cancer also?
This was not skin cancer. This was mostly, I believe, for the breast cancer and colon cancer. But these are the indications in general. The interesting point is that when you use the supplementary purified carotenoids, they do not show such effect, pointing that there may be very important difference in the vitamin which you get from your food compared to the purified or chemically synthesized components. Please remember this because we're going to be returning to something like that. Well, additional studies have been carried out, and this is the summary of 12 trials involving 300,000 people, which have discovered that high doses of vitamin A may increase risk for lung cancer. Again, I want to remind you this is not a proven thing. It's an indicator and statistic trend that was shown in the studies, but we need to keep that in mind. Okay, now let's switch to vitamin E. Again, another vitamin that is presented by a group of compounds. It's not one, it's a group consisting of 8 chemicals, tocopherols and tocotrienols, that are found in natural food sources, and they're usually found as a mixture. They're not found in the pure form in different food sources. Well, the benefits of vitamin A are protection of the cell membranes from damage by oxidation. They help to get healthy blood cell function and use of vitamin K, which is important for clotting of blood. It promotes function of a healthy circulatory system. Well, pay attention, this is a recommended daily value of 30 units. And now we're going to switch to the sources of vitamin E. Vitamin E is found in corn, green leafy vegetables, olives, olive oil, and nuts. Very nice table. Now, when we look at it, we see that these percentages of the recommended daily values are much lower than the vitamin A. And some people think, okay, you cannot get sufficient vitamin from the diet using just natural products, so you have to supplement. That is sometimes published in press. Not so much so, because if you look at this and you have 1 serving of spinach dressed with 1 tablespoon of olive oil and use it with 1 serving of shrimp, you get your half of the recommended daily value in just 1 meal and using avocados, which are right here, and nuts, and the most rich source of this vitamin, sunflower seeds, you can get all your 100% easily just using natural products. You don't need to use the vitamin unless you have a specific condition that might prevent you from assimilating all of that. Now, benefits of the vitamin E have been showing up more and more. It improves immune health, effective against cancer, Alzheimer's disease, prevents heart disease, diabetes. But there are some negative points if you overuse this vitamin, because if you like avocados and shrimp and spinach and then you take your supplement, you can get above the recommended amount. The good thing is that you cannot overuse or overdose using the normal foods, but you can overdose using your supplements. And if you do so, the result could be bleeding, and especially sensitive bleeding in the brain. High doses may increase your vitamin K requirements or interfere with the blood clotting process. And then also high levels of vitamin E may cause birth defects. There are no reports of vitamin E toxicity like there are for vitamin A. So that is a little bit safer thing. However, again, when we look at the long-term and side effects, cancer is one of the possible side effects that have been mentioned by specific studies. Vitamin D, the last one. We're going to go really fast over this. It was discovered as a dietary component, deficiency of which causes rickets. I don't know if you remember, but I remember when I was little and I was made to get a tablespoon of fish oil. I hated it. It was terrible, but now I know it was necessary. So, strictly speaking, vitamin D is not a vitamin. It is actually a prohormone. And the reason why we don't think that in strict sense it's a vitamin is because it can be made by the body. If your skin is exposed to sun, the skin cells can make vitamin D on their own. But, and it has been calculated that theoretically this is how much exposure you need to get your daily amount. But it is the ideal condition, which is usually affected by the skin tone, by the clothing, by wearing sunscreen, by cloudiness or something else. So, and age, absolutely. So it has been estimated that 50% of adults and children are deficient in vitamin D. Well, what does it do? Of course, since it affects rickets and skeletal development, it is the one that regulates absorption and metabolism of calcium and phosphorus. But lately, it has been shown that it does much more. Again, our knowledge increases, we know more, and we start getting concerned about more. Vitamin D helps cells all over the body to communicate properly, and it affects gene expression in specific cells. So this is an important vitamin. Again, it has two major forms, D2 and D3, that are essential for humans. Where can we find vitamin D3? The infamous fish oil, which is capsulated now, it wasn't 20 years ago. It is present in oily fish and in pretty high levels. Some mushrooms contain significant levels of vitamin D. Egg yolks, another reason besides choline that you probably have heard about to use eggs for food. Beef liver. However, because according to the estimate, a lot of people might be still deficient in vitamin D, even though they can make it on their own. Another source of vitamin are the fortified foods. Milk, orange juice and cereals have been fortified with vitamin D, so they can also be used as the source of vitamin D by the body.
Flaxseed oil?
Flaxseed oil, no. It is a source of omega-3, but it's not the source of vitamin D. What are the dietary requirements? Dietary requirements are pretty even across the whole age range. I don't know if you can see it, but it's about 600 units for all ages, most of the ages, and it increases as you age. Above 70, you have to target the 800 units. But now scientists are discussing that maybe we need more. Maybe these estimates are not quite precise. In any case, that's what we have right now. Now let's look at the food content. A very moderate 3-ounce portion of wild salmon. I underline wild because apparently farm-raised doesn't have that value. But wild salmon can satisfy your whole daily requirement. So eat more of the good fish that is useful for you. But even the fortified food can come together to bring you to the required daily requirement. There's one little thing about vitamin D. Even though you can obtain it from the sun, you can exposure, you can obtain it from food and even from supplement, all of those sources do not supply you with the active vitamin D. It has to be further metabolized, and it happens in 2 steps. First step in liver, second in kidney. Only then it is active, only then it is working for your body. And since, as we know, everybody is unique, everybody has different capacity to metabolize compounds, the effect of the same supplementation can be different in different people, and the requirement, of course, could be different. We need to keep that in mind. Benefits, a lot of these include newest developments, prevention of diabetes or effect on improvement of diabetes, multiple sclerosis, reduction of inflammation. All of these are important and need further investigation. Well, since the food has pretty high levels of vitamin and the supplements may have high, it can be easily oversupplied, and the results of it can be hypercalcemia, which causes deposits of calcium in soft tissues, which is something not very good. It may have some neurological manifestations, kidney stones, and some even toxic reactions, including poor appetite, weakness, weight loss, and so on. So, looking at all of these vitamins, we keep finding the same recurring theme. Vitamins are important. They're vital, you need them. You can get them from food. As you have seen from those tables, food has enough of vitamin D if you rationally approach to your diet. Your diet has to be versatile in order to obtain all of those vitamins. You cannot just eat rice and get all of that. That would not work. But if you have a very fulfilling, very versatile diet, including fish, including meat, including vegetables, you can substitute some of the sources, of course. You can satisfy your need in the vitamins. And if you go and over-supplement, it may not be good for you. It is showing in all of the vitamins, both water-soluble and fat-soluble. There are negative points. Plus, the scary cancer connection that is not really quantified or examined or proven yet. But it makes us worry what to do and how to behave. So the best recommendation that I can just logically make, going from those details, was already made by USDA in 2010. Nutrients should come primarily from foods. And the fact that keratins, which come from regular product, regular food staple, showing some protective effect and not showing protective effect when you use it as a supplement, sort of proves that. According to USDA, unprocessed food, well, not only according to that, but that's their statement, that unprocessed foods, they contain a lot more. They contain other components, fiber, other substances that can have their own benefit for you. So that is why it's better to get your vitamins from the foods. But not only, these other components may help the vitamins that you get from the same food to do their job. So natural food supply is the most useful for you. Does it mean that that vitamin supplements should disappear and not be used? Not at all. We have another direction. Yes, these supplements may be advantageous at some disease conditions, at some genetic conditions, and situations when someone needs to increase intake of a specific product. And I can tell you, finish with sort of anecdotal story. I used to have a young lady who worked as a technician in my lab. For some reason, I don't know why. She didn't eat any food that had green color. And when I heard that, my hair just went up and I said, okay, how can you survive? A lot of vitamins come from the green foods. How can you survive? Apparently, she said, her physician prescribes her a custom mix of the vitamins. That's what helps her to live like she wants, but still be healthy and do what she needs. I don't think that it is good for everybody, but it sort of reflects that there are situations that can be fixed with supplements, and we have to keep that in mind and have them. But if you are a normal, healthy person, you're better off getting your vitamins from the normal food supply. And on this, I would like to end, and thank you for your attention. I'm sorry I ran too long, but I'm ready to answer your questions if you have some.